Okay, the next little section is about laws of deductive reasoning. So we talked about the different kinds of reasoning. We have inductive and deductive. But then within deductive, there's a couple different ways to structure an argument so that you can make a conclusion. And the two laws that we're going to study specifically here, or that we studied, are detachment and syllogism. Okay. The main thing you need to know about these is that the structure of them is very specific, and you're basically looking for that structure. It's kind of hard to take a sentence or a real scenario and deconstruct it so that you can figure out if it's true or not true. But we're not really thinking about true or not true. We're more thinking about, is the argument valid? Is the logic valid? And all we need to do is to see if it follows the structure that we're talking about. So the structure of detachment here, this is the first one, is you start with P implies Q, which is just some general statement, some general conditional statement. That's statement one. The next statement is a specific case of P being true. And then the conclusion ends up being a specific case of Q being true. Okay, so let's take a look. If it's sunny, then I will go to the park. Well, that's a general statement because it could be talking about any day, right? On any given day, if it's sunny, I go to the park, right? It's not talking about a specific day or a specific case. Now, in this case, we said today it is sunny. So now we're taking this general statement and we're taking the P part, the it is sunny part, and we're saying today that thing is true, or in this case that thing is true. And then so the conclusion is, in this case, this has to be true. Okay, so it goes P to Q, general. Statement 2 is P is true, specific, and then the conclusion is Q is true, specific. So you would say something like, today, therefore, today I will go to the park. Okay. Now, sometimes I'll throw something at you where the order of statement 2 and 3 is reversed. And if that's the case, it's not a detachment. If it goes P, Q, Q, P, that's not a detachment. That's actually showing the converse, right? Q to P would be a converse, which is not always necessarily true. So that's a detachment. Okay, let's do an example and see if it's a valid example. So determine if the conclusion reached is a valid example of the law of detachment. Right, valid or invalid. Okay, again, we know that it's supposed to go, the order, statement 1 should be P implies Q, okay, and it should be kind of a general statement, and then the next statement, statement 2, should be P, a specific version of it, and the last statement should be Q for that specific case. Okay, so let's see if it follows that pattern. Okay, if I drive more than 3,000 miles since my last oil change, then I will get an oil change. So this part, I drive more than 3,000 miles since my last oil change, is P, and this part, I get an oil change, is Q. Okay, so now again, today, a specific example, today I got an oil change, but that's Q. It's supposed to be P, and it's Q. So this is definitely not a detachment. We know right off the bat it's not a detachment. Now this one happens to be a specific example of P, right? Or it's like P being true. But it doesn't matter because the order is wrong already. So this is not detachment. It's not a valid example of detachment. Just because P implies Q is true doesn't mean the converse Q implies P is true. That's not always the case. You can tell that because if you look at the truth table for the two, the truth table for the original statement and the converse, they don't match. They don't always match, right? Notice these don't match and these don't match. So you can't say that these are equivalent statements because their truth tables don't match. Okay, syllogism. So syllogism has, again, a very specific structure, and syllogism is basically like transitive property only for conditional statements. So our transitive property of equality is if A equals B and B equals C, then A equals C. Right? So it goes A, B, and then it starts, the second statement starts with the end of the first. So these two guys match. And then the last statement is you just skip over the middle two. Okay? Now for syllogism, syllogism is actually for conditional statements. Okay, so instead of A's, B's, and C's, we're going to use P's and Q's, and instead of equals, we're going to use our conditional symbol. So we have P implies Q, that's the first statement, and then the next statement has to be Q implies R. So really, really important that the second statement begins with the end of the first statement. These have to be the same. If they're not, then it's not setting it up for a proper syllogism. Okay, and the last statement, the conclusion, is that this guy must imply this guy. P implies R, and that order is important. You can't reverse the order. It has to start with P, and it has to end with R. It has to start with the very beginning of the first one and end with the very end of the second. Okay, that's the structure. If it doesn't follow that structure, it's not syllogism. Okay, let's take a look. P implies Q. If I get up early, so I get up early is P, then I will go on a walk before work. Okay, notice this is Q. So statement 2 has to start with something about me going on a walk. Okay, it has to. Statement 2, if I go on a walk before work, then I will drink a protein shake. Okay, cool, it does. It starts with Q. That's exactly what we want, Q. Notice that these match. The end of the first statement is the same as the beginning of the second statement. That's super important. Okay, then the last statement here, or the hypothesis of my second statement, is a totally different idea than we've had before. So we're going to call that R, because that's the next letter in the alphabet after Q. So this conclusion then, if I have P to Q and Q to R, would that be P goes to R? The very first statement of the first guy matches to the very last statement of the second guy. Okay, so it would be, if I get up early, then I will drink a protein shake. Okay, now you might be thinking about that and be like, well, I don't know if that's true. I don't know what your life is. I don't know you. I don't know if you drink protein shakes. I don't know if those things necessarily follow. I don't know if you always drink a protein shake every time you go on a walk. But that's not what we're after. We're not trying to figure out if this statement is true or false. We're not trying to look into clues of my life or whoever wrote this, whoever's stating this. We're not worried about that. What we're worried about is the logical structure. So assuming that this is true and assuming that this is true, we would have to say then that this would have to be true if these two guys were true. If P implies Q, which we're assuming, and Q implies R, which we're assuming, then it has to be the case that P implies R, regardless of, what it looks like. Okay? So don't worry about the true or false, or if you think it, makes sense or not. You're looking at the structure of the argument. And the structure of the argument, this is what you would have at the very end. Okay, 28. Let's keep going. Okay, so determine if a conclusion, if the conclusion reached is a valid example of the law of syllogism. Okay, so again, we're going to look for the same structure, right? We want P implies Q for our first statement. Q implies R for our second. We want the beginning of the second statement to match the end of the first. And then our third statement, our conclusion, should be the very first statement of the first part of the first statement matches the last part of the last statement. Let's take a look. Okay, a person likes bananas, that's P. Then they like strawberries, that's Q. Okay, a person likes strawberries. Well, that's Q, right? The beginning of the second statement matches the end of the first statement. That's what we're supposed to have happen in a syllogism. So far, so good. Okay, so Q is true, they like strawberries. Then they also have to like apples, which is R. Now you might be thinking to yourself, I don't believe that's true. Well, it doesn't matter right now, right? We're not talking about true or false, we're talking about building an argument. So let's assume that this is true for a second, and let's assume this is true for a second. Okay, if those things happen to be true, which maybe they're not, but if they are, then this is what we're after. If this is true and this is true, can we say that this is true? So let's take a look. A person likes bananas, that's P, and then they like apples, that was R. So P goes to Q and Q goes to R, which means P goes to R. P implies Q and Q implies R. That has to mean that P implies R. That is the structure we're looking for. So regardless of whether you think, you're like, well, hold on, I know plenty of people who like strawberries and don't like apples. That's not the point. The point is to build an argument based on two statements and form a conclusion. So although you might argue that this is not true, it is valid. It's a valid logical structure. Okay. Okay. In the next problems, we are going to use, we're kind of shifting gears out of reasoning. We're still going to be using reasoning, but from directly studying definitions and stuff. We're going to do more of an algebra kind of section. But in order to get these equations set up and solved for, we're going to have to know some facts. Okay. So let's take a look at number 29 and 30. And I think we might just keep going and do some of these on the next page. If we have time, we'll see. Okay, so 29 and 30. It says use facts, theorems, and definitions of angle and segment relationships to set up equations and solve the problems below. So I need to know some facts, theorems, definitions. Okay, two angles from a linear pair. Well, that's a definition of what we're going to have. We're going to have to know the definition of linear pair, and we're going to have to know some facts about linear pairs. Okay, find both their measures if one angle measure is this and the other angle measure is this. So what do we know about linear pairs? Well, a linear pair, if you think about it, what does linear mean? It means line, right? So this is a line pair. Linear pair is a pair of angles that make a line. So something like this. Okay, they have to be adjacent. They have to form a straight line. The definition is that their non-common sides form opposite rays. So if this is the vertex, you have a ray going this way and a ray going this way. And this is the side these two angles share. So these two angles, their non-common sides form opposite rays. So that's a linear pair. And what do we know about the measurements? Since we're talking about measurements, we know they have to add up to 180. So the idea is, because they're in a linear pair, the key fact there is that the measures add up to 180. So I use that fact to be able to set up an equation that I can then solve for x. Once I have x, I can plug it back in and find out what the actual angle measures are. Okay, so let's combine like terms. 4x and 3x is 7x, 10 and negative 5 is positive 5, equals 180. Okay, so we're going to subtract 5 from both sides. And we're going to get 7x equals 175. We're going to divide both sides by 7, and we're going to get x equals 25. Okay, now that's not our answer. We found x, but what we really wanted is find both their measures. We want to find these angle measures. So we need 4 times 25 plus 10, and we need 3 times 25 minus 5. And that's going to give us our two angle measures, and they better add up to 180. Sorry, minus 5. Okay, so 4 times 25, think quarters. 4 quarters is $1. So this is 100 plus 10, 110. 3 times 25, that's 75 cents, right? 3 quarters is 75 cents. So 3 times 25 is 75, minus 5 is 70. So these two angles right here, notice that they add up to 180. They're supplementary. Well, they should, because they are a linear pair. So here are our two angle measures. So this is huge. Knowing facts about linear pairs is going to be an important part of this chapter. It's an important key concept. Another theorem that we just proved from the last section that we did, the angle proofs too, is something about vertical angles. We know if two angles are vertical angles, they are congruent. So angle 1 and angle 2 are vertical angles. So that could look something like this. Okay, so what do we know about vertical angles? Well, vertical angles are angles that their sides form two pairs of opposite rays. So opposite ray, opposite rays, right? Those are the sides of the angles. So those two guys you could call vertical angles. Also, these two guys would be vertical angles to each other. So angle 1 and angle 2 have to be congruent to each other. Okay, and congruent means same measure. So we start with the idea about what vertical angles are. Then we pull out the fact, hold on a second, vertical angles are congruent by the vertical angles congruence theorem that we proved. Therefore, the measure of angle 1 equals the measure of angle 2. So we're not really doing a proof, but we're using kind of some similar reasoning, right? A chain of reasoning, deductive reasoning. Okay, if these are vertical angles, then they are congruent. If they are congruent, then their measures are equal. If their measures are equal, then we can find x. So let's combine our like terms here. Or I guess maybe balance the equation should be a better way to say that, since these aren't on the same side. Okay, so minus 7, we're going to get 6x equals 71 minus 7, which would be 64. Okay, now if I recall, this doesn't come out super nice, so let's figure out what that is. Let's ask Siri. Hey Siri, what is 64 divided by 6?
The answer is about 10.6666.
Ooh, thanks Siri. That's actually 10 and 2/3. So x equals about 10.67, right? Or 10 and 2/3. Okay. Now that's not what we were after. We were actually after the angle measurements. Oh no, wait. Find x. Ha! We were supposed to find x. Cool. We did. If we wanted to find the angle measurements, we could plug those measurements back in. So we could take this number and multiply it by 4 and add 7. Let's figure out what that is. Forgot my calculator in the room, so I got to use my phone calculator. Sometimes this is hard to use. So let's go 10.67, we'll estimate there. And we're going to multiply that by 4 and then add 7 just to see what it is. Okay, so about 49.68, but like we rounded, so that might be a little bit off. Now, angle 2 has to be the same thing, right? Because they're congruent. We would expect to get the same thing. So let's double check and see if we get something similar. So for angle 2, we should get that 49.67 or something really close to that, or 49.68. So we'll do 71, we're using this guy right here. 71 minus 2, oh shoot. Let's see if we can do times. Ah, there we go. Okay, so we got 49.66, which is not exact, but again, we rounded, so these should be exactly the same. And if we, did it with fractions and stuff, we'd basically get 49 and 2/3, which are congruent to each other. So in this case, it just asked us to find x, so we didn't have to go that extra step. But if we did, we could verify that, yeah, that's the right x because it gives us congruent angles. Okay, that's the end of page 2, and just looking at the time, I think we're gonna stop there for this video. I'll come back in the next video and start the next page, and we'll go from there.